want to at some point, just because, like, I mean, I do like math. But yeah, at some point I will.
All right, so so let's talk about the quiz. I'll talk about the grades in a second. So the quizzes were worth 5 points, so it's 2 points a question, so that's 4 points, and then 1 point is pretty much almost for free. Just submit it. Now, let's just go over this here. So you have 5. You had 1. Then you had 3 here, 2 here. So then it was, give me a second here. All right, so the part A on question number 1 on the quiz was limit as x approaches 5. And by the way, just in the future, whenever I grade a quiz, I will always go over the next class meeting. So in case you're wondering why I took points off. So limit as x approaches 5 here. From the left side, it's going towards 1. The right side is going towards 3. They're not hitting the same number, so it does not exist. Part B, what's f of 5? Well, that's where it's filled in, so it's 3. Now, number 2, I want to talk about a little bit more detail. You guys, when you draw a graph, well, some of you did it really well, some of you not so much. You got to show me more points. You can't just give me a graph that looks like this. I need to see more points than that. I mean, this doesn't tell me what, if you know how the slope looks like, what points does it go through. So do not graph something that looks like that. So instead, you got to do this. So we got 1, 2, 4. So the f of x equals x plus 3 if x is greater than or equal to 3. So that's 3. Greater than or equal to 3. So that means, sorry, greater than or equal to 0. So x plus 3. So 3 is the y-intercept. Slope is 1 over 1. So that's up 1 over 1, up 1 over 1. It's going to look like that. And then f of x equals 1 minus x. So that's the same as negative x plus 1. So 1 is the y-intercept. And then slope is negative 1. So that means down 1 over 1, down 1 over 1. So if you go the other direction, it's going to be up 1 to the left 1, up 1 to the left 1. So it's this line right here, right? But this line, you're only going to use when x is strictly less than 0. So it's going to be open circle because it's strictly less than, and that way. So you see how I have some points here so you can see where it's going through. So do that, and then that's how you graph that. So so I'm going to also answer a few questions that I've been getting emails from just different students from different classes. So on a quiz or a test, you cannot use an iPad. You can use a page of notes for either a quiz or a test, and I told you the reasoning why. So just keep that on the down low. You don't have to go say it to everybody else outside of the class. So yeah, you can use a page of notes front and back, but it's got to be a page of notes, like on a regular sheet of paper. Because on iPad, I don't know what's going on there. So it's got to be a regular sheet of paper. What else was I going to say? A few other things I want to discuss here. When you scan, you need to use your phone. Learn to do it with your phone. I know some people do it with their printer, but I've been teaching for a semester and a half, and things don't work out well with printers on exam time. So if you do use your printer, don't let me know about it, because I'm assuming you're doing it with your phone, because I do not want to hear this on the test day. My printer is acting up. It's taking so long to scan it. It's taking 10 minutes. I'm almost done scanning. why don't you just use your phone? Click, done. Learn to do it with your phone. There's a bunch of YouTube videos that show you how to scan and create a PDF file with your phone, iPhone or Droid or whatever. That's that. Of course, you can use your printer to print. That's how else you're going to print. And that's pretty much it. Oh yeah, as far as the grades go. So I would advise you don't pay attention to the grade tab so much. Yeah, you can use a page of notes on the quiz as well. The reason for that, because Cassandra just asked, can we use a page of notes on the quiz as well? Yes, because it could be taped behind the computer anyway, on the wall anyway. I mean, how do I know? So I'm just saying, yes, you can use it. That way, everyone is on a fair playing field. But yeah, if we were back to regular times in class, yeah, you wouldn't be using the notes. But I can only do so much here. Either that or use Proctio and invade your privacy. I don't even know how Proctio works, but I've heard this invasion of privacy, which scans your whole room, your closet, everywhere, no, underneath your bed. No, I'm just joking. I made that part up. I figured if the state of California really cared about the standards of the education, then they would at least somehow figure out a way to have us meet on campus for 3 times for the semester at least for the exams. But they said no, just do everything online. All right, we'll do everything online.
Especially for math.
I mean, I don't really see how, like, if we got 30 people in a class, we can go to a big old room, everyone wears a mask and a face shield. We can get it done. But it's just, I think no one wants to do the work. So it's just easier to have them do it at home and cheat. I mean, they don't say the and cheat part, but never mind. You didn't hear that. But so what I'm going to do is you can use a page of notes. There's no way around that, in my opinion. But do not use an app. You got to do the problems the same way as I do it, or the book does it. You got to use similar notation. Talk about that later. Yeah. Oh yeah. So as far as the grades go, you will. Here's the thing. We only had one quiz. So like if you missed one quiz question and you got -2, so that's 3 out of 5. You're all, okay, that's a 60%. I'm getting a D in the class. Well, don't freak out. We're gonna have more quizzes. We're gonna have another one this Thursday, and eventually it'll average out. And I drop the lowest quiz. The main thing is the quiz, so you learn from your mistakes, so that you do well on the test, which is worth a lot more. So please don't even look at the grades portion of Canvas until you have your first exam. Now, I may have messed up on the setting there because some of you did not turn a student information sheet in and it just says 0. I don't know how to turn that off. I haven't graded the student information sheet. It's just part of your participation grade. So I put it's worth 5 because I had to put a number, but if you didn't turn in a student information sheet and you want to turn it in late, I think actually everyone here did turn it in. This was my only class that I think was perfect. I'm not sure. But if you want to email it to me, you can if you haven't submitted it, but because you can't do it on Canvas anymore. All right, any questions on that? Oh yeah, and somebody asked me about extra credit for going to SI. It's not just a no, it's a hell no. You're already doing an online test using your notes. What do you want? You want me to make coffee for you too while you're taking the test?
That would be nice.
I like cream.
Decaf.
Miguel asked the question, could you go over number 15 on 2.3? Let's see, it depends if I like the question. Yeah. All right, let's do that. In fact, I was going to have you guys do this. So number 15, limit as t goes to -3 of of this expression. So if you try to plug in -3, you're going to get 0 over 0. So you simplify. Oh, is Aaliyah here by any chance? Maybe she's on the other screen.
I am here. Hi.
Oh yeah, how's the? Are people coming into the math lab? I mean, the SI.
Yes, this class has the most attendance. I am glad.
Oh, okay.
The first day I kind of had an issue logging in, and I like walked in and I had like 18 people in the waiting room, and I was very happy about it.
Very good.
Yes, you guys keep it up.
How about the college algebra class? Is that decent?
Yeah, that had like 9.
Mm-hmm.
Yeah, so not as much as this class, but still good enough.
So two numbers that multiply to 3, we're going to go with +3 + 1. So the inner product is 1t, outer product is 6t, which adds up to 7t. So let's see here. The t plus 3's cancel out. You get limit as t approaches -3 of t minus 3 over 2t plus 1. So now we're going to plug in -3. So we get -3 minus 3 over 2 times -3 plus 1. So we get -6 over -5, which is 6/5.
Professor, do
Is
you have
that-
time to? Sorry, do you have time to squeeze one more problem in? I apologize.
Yeah, I was going to talk about some stuff because I rushed through the intermediate value theorem last time. I was going to talk about that too. Yeah, go ahead.
2.4, number 21.
Is that the delta epsilon stuff?
Yes, sir.
Okay. Well, I'll do it for you. It's just that I didn't do that last time. I did do a fraction one where you got to factor the top and cancel it out. I thought I did number 21 the day after I assigned it. No.
Oh, yeah, I think you might have. I apologize. I think I might have missed that. It's okay. We don't have to.
I'll do it for you again. It's not going to be on this week's quiz, but we'll discuss delta epsilon before the test again. But hold on. Let me Daniel, number 2.5. Okay, let me see here because there's a certain things I want to cover right now. Then I'll get to your questions. I do have some stuff that I still want to touch on. 2.5, number 7. Did I sign that? Yeah, I did. Okay, let me do 2.5, number 7. Do we have a quiz every week? Well, in theory, probably not every week, but most weeks. This week we are. If I'm bombarded with work, like I still have to grade your exams, I haven't even got to your exam yet, then I'm probably not going to give a quiz. But yeah, we're having a quiz right now. This Thursday. Let's do number 7 here on 2.5. Because it takes longer to grade the exams when it's not actual paper. Sketch the graph of a function f that is continuous except for the stated discontinuity. All right. Removable discontinuity at 3. So remember what it, before I even do the problem here, let me just write it out. Removable at 3, jump discontinuity at 5. All right, so remember what a removable discontinuity is. It looks like that. A jump discontinuity looks something like that. Just FYI. So 1, 2, 3, 4, 5, 6. So removable discontinuity at 3. And so that would be an example of a problem with a removable discontinuity at 3 and a jump discontinuity at x equals 5. Does that make sense, Daniel?
Yeah, it does. A lot better, actually. Thank you.
And 39. We'll talk about 39 later. There's certain things I want to talk about. Let me talk about the intermediate value theorem again. So, intermediate value theorem. By the way, did you guys watch the Super Bowl?
It was a slaughter.
Yeah, I thought the game was not that fun. The Super Bowl MVP should have been the streaker. That was the most entertaining part of the game.
He scored before the Chiefs did.
Damn.
I like how he slid at the end because the guy was going in to clock him, and he slid right underneath him so the security guard didn't hit him.
They said he bet that there was going to be a streaker on the field, so he won like $35,000 off a bet and paid like $1,000.
I saw that online. I don't know how true it is. The little thing that the meme I saw online is that he put the bet himself, and then he went to do it. But you never know with those kind of bets. I mean, technically he wasn't streaking because he was not naked. So I wouldn't gamble that kind of money.
How about those Lakers though?
Oh, yeah, good. Yeah, the problem with the Chiefs, though, there's just their offensive line wasn't protecting them. So, I mean, the pass rush was getting, I don't know, you can be a great quarterback, but if you're not getting any time, you can't do anything. Anyway, let's go with calculus here. Sorry. Intermediate value theorem. If F is continuous on the closed interval AB, and K is some number between f of A and f of B, then there exists at least one C in the open interval AB such that f of C equals K. So let me explain. So let's say you got A here and you got B here. So that would be f of A. F of A is the value, the y value that corresponds with A, the function value A. And f of B is the output when you plug in B. K is a y value. So we're saying K is some value between f of A and f of B. So in this case, let's say K is right here. Well, the intermediate value theorem says then there has to be some value C between A and B where f of C equals K. Now, I did an example for you last time, and we actually found the zero. This time what I want to do is, I found the C value. I want to do number 53 from the homework for you. So pay attention to the wording. It says use the intermediate value theorem to show that there is a root of given equation in the specified interval. They didn't actually say find it. Well, so it's asking me, Damaris, is this IVT continued? Well, kind of, yeah. I just rewrote the theorem again. I'm trying to explain it again. So now I'm going to do number 53 from the homework. So number 53 says x to the fourth plus x minus 3 equals 0. So keep in mind, we just have to show that there's a 0, there's a root. That this function will equal 0 for some x value in in the interval 1, 2, in the open interval 1, 2. So how the heck do we use the intermediate value theorem here, since in intermediate value theorem, the way I explained it is you have to have an f, like a function. So here's what you're going to do. You're going to say, all right, let f of x equal x to the fourth plus x minus 3 on the closed interval 1, 2, because you need a closed interval. So here's how you do the problem. So everything above this line is what's given to you, and everything underneath the line is what I'm doing. So if f of x equals x to the fourth plus x minus 3, I want to know, there's some, and I'm going to let k equal 0. Why am I going to choose k to be 0? Because it's equal to 0 in the problem right here. So let's see if we can apply the intermediate value theorem. Is f of x continuous? Yes. So you would say, yeah, f of x is continuous on 1, 2 because it's a polynomial. What's f of a? So what, in this case, a is going to be the 1, b is going to be the 2. So what's f of 1? So it's 1 to the fourth plus 1 minus 3. So that would be 1 plus 1 is 2, minus 3 is negative 1. What's f of 2? That's 2 to the fourth plus 1 minus 3. So that's 16 plus 1 is 17. Minus 3 is 14. Now, so notice k equaling 0, that is between negative 1 and 14. So since k equals 0 is between the f of a and f of b, and f of x is continuous, then the intermediate value theorem, IVT, applies.
Excuse me, Professor.
Yeah.
Don't we have to plug in for f of 2 on all x values?
Oh yeah. So I'm sorry. That's why I missed. I was thinking that 14 doesn't look familiar. So you're supposed to plug in 2 here. Yeah. But it still applies. So that's 16 plus 2 is 18 minus 3 is 15. Yeah. So this would be a 15. Thank you. But it still applies because 0 is between negative 1 and 15. Did you guys all catch that? No, you
So
didn't, because you didn't say anything.
we caught it, but so you can are you choosing k to be 0 just because this polynomial is equal to 0, or could you choose whatever you
No,
want?
no, that's exactly why.
Okay. So as long as our k is between, or using the intermediate value theorem.
Yeah,
is
k has
correct.
to be between f of a and f of b. So in this
Okay.
case, 0 is between negative 1 and 15. If
And
it
most-
wasn't, then we can't use the intermediate value theorem.
Oh, I see. Okay. Then you would say it wouldn't, or would you just use a different method?
Well, it has to, because the directions say use the intermediate value theorem to show that there's a root. If I can't use the intermediate value theorem, then it's a trick question.
Okay. I thought there was another way of writing this if it wasn't.
No.
I see. Okay.
So the intermediate value theorem applies, and then there has to be a root. And that's it. You don't actually find the root because this is too tough of a problem to do. It's a 4th degree polynomial set equal to 0. So the one that I chose as an example last class meeting was an easy one. It's a quadratics, and it factored because I just wanted to show you how it works. This one, the book, even the author is not intending for you to do the problem. It's just saying, now I can tell you for sure with certainty that there will be some x value that's a 0, some c value that you can plug in for x will give you 0. And that c value, at least one of them will be between 1 and 2. I just showed you by the intermediate value theorem. It's probably some nasty number, but you don't need to figure it out.
If the equation that you're given isn't equal to anything, what would you use k? What number do you?
It all depends on the problem. An equation has to equal something. Let's do number 55. I'm not going to do number 55. I'm sorry. I'll start you off. I'll show you and answer your question. So number 55, It's the same directions. Use the intermediate value theorem to show that there is a root. And it gives you e to the x equals 3 minus 2x on the interval 0, 1. So you're saying, wait a minute, what do I do? This is not equal to a number. Well, move everything to one side. I'm going to move everything to the left and say e to the x plus 2x minus 3. So I accidentally pressed the home button. I am going to set it equal to 0. So in this case, I will let f of x equal e to the x plus 2x. I could have left the 3 on the other side and had k equal 3, but I just prefer to have everything on the left and have k be 0. It works the same way. So you could have left the number 3 on the right and had, say, you know what? So I'm going to do that, and then on 0, 1, and let k equal 0 because it's equal to 0. Someone else doing the problem could have said, hey, e to the x plus 2x. And if the 3 is on the other side, it would be positive 3. And then they would say, let k equal 3. Because if you move this 3 to the other side, it would be a positive 3. So either or would have worked, and you'd still get the same result. Was that what you meant?
Yeah, thank you.
All right. So that's the intermediate value theorem. I do want to talk about one other problem here before I'm assuming some of you had issues with number 43 as well, the absolute value problem. Anyone? Or not, sorry, not 43 on 2.5. 43 on section 2.3. We did 2.5 last time, right? Did we do 2.3 and 2.5 last time, or just 2.5? Oh, we finished up 2.3. We finished 2.3 and we did 2.5, right?
Yes.
Yeah.
Yep.
So I will talk about this one problem because my morning class at Cal State Fullerton had issues with a question like this. So it got cold again today, huh?
Very actually. Yeah.
Okay. So now this is a little, this one, it's limit as x approaches 0.5 from the left side only. This is a one-sided limit question. So I'll get back to this main problem in a second, but first let's just worry this absolute value on the bottom is bothering us. So
Professor,
yeah,
really fast, the previous question, the answer for the second one for B would be plus minus infinity, and I was wondering why that was the answer.
B for 55.
Yeah, like there's A and B. The
There's
answer
there's an A and a B.
yeah, because
No.
you do 0 and you do 1. And they just put the answers as A and B. Like part 1, part 2.
Well, F of A and F of B.
Yeah, sorry. So I was just wondering why it's infinity.
So did you use your F of X to be this one, let's say? Are you talking about that one?
Yes.
So F of 0 would be e to the 0 plus 2 times 0 minus 3. E to the 0 is 1 minus 3, which would be negative 2. F of 1 would be e to the 1 plus 2 times 1 minus 3. So it's e 2 minus 3 is minus 1. It's not infinity, it's e minus 1.
Okay,
Ooh.
that's what my book said, so maybe they're
You're looking at probably the wrong section. That was 2.5.
okay. Thank you, Professor. Thank you for
Did you
going.
look at the wrong section?
Yeah, I'm so sorry.
It's okay. I remember when I was a student, sometimes I do a problem, and when I'm writing the problem from the book, like half of my equation is like number 47, the other half is from number 48. And I'm like, the answer is not the same as the back of the book. I'm like, I wrote the wrong problem. Half of it is like the left side of the equation is number 47, the right side of the equation is number 48. No wonder this doesn't make sense.
I've been doing that a lot, actually.
All right, so here's what we're gonna do. I'm gonna factor out an x squared. Now, absolute value of x squared is just x squared because it's positive x squared. So then we still got an absolute value of 2x minus 1. Well, let's worry about that. Absolute value of 2x minus 1, that will be equal to 2x minus 1 if 2x minus 1 is greater than or equal to 0, or the opposite of 2x minus 1 if 2x minus 1 is less than 0. So then this, if you move the 1 over and divide by 2, x is greater than or equal to 1/2. Here is x is less than 1/2. So going back to the main problem up there, you got the limit as x approaches 0.5 from the left side of 2x minus 1 over the absolute value of 2x cubed minus x squared. Well, since we're talking about as x approaches 0.5 from the left side, that means we're talking about numbers like 0.4, 0.3, which are less than 1/2. So in this case, absolute value of 2x minus 1 is going to be that, because we're talking about numbers that are less than 1/2, because it's from the left side, right here, left side. So this is going to be equal to the limit as x approaches 0.5 from the left side of 2x minus 1 over, well, first of all, I'm going to factor it, so it's x squared times the absolute value of 2x minus 1. Next, limit as x approaches 0.5 from the left side of 2x minus 1 over x squared times so what happens here, because it's left of 1/2, absolute value of 2x minus 1 is opposite of 2x minus 1, which is the opposite of 2x minus 1. And that's really the hardest part. From here, you should be able to take it. The 2x minus 1s cancel out. So you got the limit as x approaches 0.5 from the left side of 1 over negative x squared. So you just plug in the 0.5, so you get 1 over 0.5 squared, and then you got a negative sign. So the answer is going to end up being -4.
Once again, why did you give the x a negative before the right here where it says limit x approaching 0.5 from the left side?
Right here?
Yeah, right there, right there.
Yeah, because absolute value of 2x minus 1 here is negative, the opposite of 2x minus 1 when we're talking about x values that are less than 1/2.
Oh, okay, I see, I see. Okay.
All right, so let's start 2.6. We're only doing one section today, but
Professor, before you move on, could you explain where you did the absolute value and then you split it to two expressions? Could you explain that portion?
yeah, so remember absolute value of something is equal to itself if it's greater than or equal to 0. But it's equal to its opposite when it's less than 0. It comes from this. Remember I said the absolute value of x is equal to x if x is greater than or equal to 0, but it's equal to its opposite if x is less than 0. That's the definition of absolute value. So in this case, instead of x, we have 2x minus 1. So our 2x minus 1 is like the whole thing is like our x. It's equal to itself if it's greater than or equal to 0. It's equal to its opposite if it's less than 0.
And then how did you get the 1/2? Is that from the problem?
Oh, just take this inequality and solve for x. Move the 1 over, divide by 2.
Okay, thank you.
All right, so are we good? All right, section 2.6, limits at infinity. And horizontal asymptotes. Give me 1 second here. They actually talked with vertical asymptotes in 2. Okay. Let me review a couple of things from college algebra here. So if you remember, we have f of x equals, let's say 5 over x minus 2. In this case, vertical asymptote is where the denominator is 0. So in this case, a vertical asymptote is at x equals 2. It's after the fraction is simplified, it's all the x values that make a denominator 0. But be careful, because if you have g of x equals, let's say I have 8 over, no, actually not 8 over, x minus 3 over x squared minus 5x plus 6. In this case, you would say, wait a minute, so is it x equals 2 and x equals 3? No, because you got to simplify it first. So if you were to reduce this, so you have x minus 3 and x minus 2 here. So after you reduce it, the x minus 3's cancel out, and you get 1 over x minus 2. So in this case, it's still the vertical asymptote is just x equals 2. So remember, they're the x values that make the denominator 0 after it's simplified. So again, a vertical asymptote here would be just at x equals 2. So that's how you find the vertical asymptote. Now we'll deal with horizontal asymptotes in this section as well. But first, let me go over the definition of the calculus definition of what makes something a horizontal asymptote, what makes something a vertical asymptote, involving limits. So here we go. First, let's talk about horizontal asymptotes. Let me write a little bit better. All right, so we'll say y equals L is a horizontal asymptote if either limit as x approaches infinity of f of x equals L, or limit as x approaches negative infinity of f of x equals L. So let me show you by giving an example. So for example, let's say you got y equals 2. So for y equals 2, in this case, L being 2, is a, let me draw this a little bit further. So y equals 2 is a horizontal asymptote if either one of these is true. Either as you go, as x gets really large, goes towards infinity, it merges with it, number L, in this case 2, or as it's going towards negative infinity, it's going towards that number. And it doesn't have to be from the top, it could be from the bottom, either or. So if one of those is the case, then you would say, well, that y equals 2 must be a horizontal asymptote. And this is L being 2. So that's what it's saying involving limits. Any questions on that? So either it's got to go to infinity, merge with the line asymptote here or here. Now let's talk about vertical asymptotes. Hey, we have perfect attendance again here today because it's 31 students plus Aaliyah, and then me and my iPad, that's 2 more, so 34. Very impressive. Even Daniel showed up.
Of course. Always.
Aman and Mahmoud semi showed up. You know, they're at least logged on while they're watching TV. Oh, that's okay. There's one student in my evening class. Oh, Aaliyah would know this. I think she was like, had her computer on, but she was somewhere else. She wasn't even in the room. Oh, I'll tell you who it is later. I think it was practice for Cypress College. Vertical asymptotes. Oh yeah, so let's do that. We call that x equals a is a vertical asymptote if at least one of the following is true. So I'm not going to write it properly. I'm going to write it like all mixed together, but I'll show you where you can find it properly in the book because I don't want to write this 6 times. So if you want to find it in the book, it's page 90. I know it's a previous section, but so if you go to page 90 in your book, on the bottom, you'll bottom rectangle there, you'll see what I wrote here 6 different times, but with a slight change in each one. So one will be limit as x approaches a from the right side of x goes to positive infinity. Then it would be from the right side going towards infinity. Then it would be just in general going towards infinity. Then from the left side, and then going to then the same 3 again going towards negative infinity. Basically 6 different scenarios. If any one of those is true, then it's a vertical asymptote. Basically what that's saying is, let's say x equals a, let's call it x equals 2 right here. What would make this a vertical asymptote if any one of these 6 is true? Limit as x approaches 2 from the left side is going towards infinity, or from the right side is going towards infinity. Or just the limit in general is going to infinity. Of course, that will mean both. Or maybe from the left side it's going towards negative infinity, or from the right side is going towards negative infinity, or in general, which means both. So that's another 3 cases. So that's why they wrote it out 6 times with a slight variation. If any one of those happen, then it makes a vertical asymptote. So I hope you don't mind me not writing that 6 times. It's page 90 on the bottom of it if you want to see it written out 6 times. All right, so now before I do some examples, do you guys want to break?
Sure.
So we'll go 12-minute break. We'll start back up at 4:15.
Okay. Thank you.
Uh-huh.